Hi, welcome back. This is Calculus 3, and this is our kind of final extra credit project. And what I want you to do is basically use Python. And it's fairly simple. Don't be intimidated if you've never done programming before. It's no big deal. It's mostly just copy and paste and edit. But anyways, we'll use Python to answer 10 WebAssign questions of your choice. So for each question you do, I want you to copy and paste all this stuff into a Word document. First, you need the question, obviously, from WebAssign. Then you need to show me the code, and then you need to show me the code evaluating to the answer. Okay. Each one is going to be worth 2 points for a max total of 20 points. So where do you go to figure out how to do Python and calculus? It's this guy's channel. I saw it I think it was linked on Facebook. But just a really, really well done video. Mr. P Solver, I guess is the person. I don't know. But you could watch his video and he'll walk you through it. I watched it before. I don't honestly remember it. But the thing I like is the link to this code down here. So if you click on that, it's going to take you to this page, which lists all kinds of, they're basically just functions where you could plop in your information, push enter, and the computer will evaluate for you. So you may not necessarily have, for example, gradients on your calculator, but you could go here and compute it. Obviously, you could go and, there's software out there floating about, which will which will be easier for you, but I think in the long run, having a little bit of experience with a compiler is going to help you, rather than always, because there's not going to be a math way once you get into your job for you. You're not going to have Symbolab there for you. So you're more likely to have some sort of computer program to have to stomach. So, in my opinion, and who knows what computer program you'll be using, but you'll most likely be using something. So anyways, this is it, guys. This is the project. So anyways, yeah, you get all your code here. So we need a compiler. I put the links here, and then I'll put this this OneNote document in the Blackboard tab. So if you go to the Blackboard, I probably already have it open somewhere. This is the other class, 2310. Probably go to projects, go here, and I'll put it in there. Okay, I'll put it in the projects. Oh, wait a second. I had an extra credit project somewhere. I want to put it where the extra credit thing is. So sorry. Let's not put it there then. Well, if they were nice enough, there it is. Okay, so where the heck did I put it? Is this 2310? Yeah. Is this the right semester? Yeah. Did I put it in course content? I mean, it's in course content, yeah. So you see I already put a bunch of stuff up in here. The NASA project was kind of a group project, just because I figure people need more socialization these days. I wanted you to work together on this thing. I think only 3 people kind of did it, but there's another paper in here using spherical coordinate systems, and obviously in Ukraine right now, a lot of the math is probably dedicated to working with radar installations and that kind of stuff. So they use spherical coordinate system. You could take a peek at that if you want to. And then, of course, I have the WebAssign keys that I did for my own personal work, just in case people ask me questions. I always make sure I do all the homework problems, and just so I know you're on track and where you should be and what you should know when I write my tests and everything. So anyways, yeah, so what you're going to do is go into WebAssign, wherever the heck that is. Go to 2310, go. Wait a half hour because your computer is slow. Pick your favorite section that you want to apply these formulas to. So I'll pick 15.2. That is where we get the beginning of line integrals. Just go to some question like this guy will do. Number 9 seems easy enough. For the compiler, we're going to use this collab researchgoogle.com link. So you just click on that, and it should pop up somewhere. I don't want to use that web browser, though. So what I'm going to do is, hopefully I can copy this. Please let me copy this. Yes. Control-C it. Go over here. Control-V it. Push Enter. and it should pop this thing up. You're going to hit a new notebook. I don't play around with this other stuff. I just hit new notebook and go right there. And then you could copy and paste your code into this thing, into this line right here with the play button. So the first thing you want to do is basically load all these packages, right? So the computer probably, it needs to unpack stuff. It's all this junk is kind of encrypted in a way that it's small, and they need to unload it before you do anything. So just go in there, unload it. So I should be able to hit Control C, Control V, Control C for copy, Control C for paste, and then hit the little play button. Okay, think about it, and it should give you a little check mark beside it saying it's okay. Yay! And then if you need to add in, more code now for your problems, you just hit the plus code button. And then you can put in, whatever you need. So this is going to define some variables for us. And it's not going to hurt you to run too much code. If you want to literally go through and please copy and paste. If you want to literally go through and run all of this code by copy and pasting it over here. And there may be some way to run a compiler through that thing I have. It's just I'm not all that, I grew up with a TRS-80, First language was BASIC, so I'm a long way from home here, but I know what I'm showing you works. Okay, so there's that. Right. So go to your favorite WebAssign problems. You don't have to do the chapter 15 problems if you don't want to. Just find some such that you think you'll be able to handle working with the code and all that jazz, and then find where it is. So they have arc length stuff, chain rule stuff, gradients, directional derivatives. We didn't do the Lagrange multipliers. It's just a nice way of handling optimization problems. And they got multiple integrals, all the vector calculus stuff. We need the line integrals, right? So we need basically, what the heck is what I need? I need this thing, right? So I'm gonna copy and then paste this junk right here. Is kind of what I believe I need. So copy that and paste it and run it. And all it's doing is kind of setting up the functions that I'm going to be using in order to pull this junk off. The matrices, they're at the bottom. Well, you have components for your vector field, and then you have these matrices where you're going to be putting in the components. You'll have a matrix for the R of t, the curve, the vector value function for the curve, and then you'll have the vector field, a matrix for the vector field. So let's make sure I get all the little bits and pieces I need to pull off the code. And it's better to put more code in. Even if you don't understand what the code is, it's better to err on the side of copying and pasting more than less. That way you don't miss any of the little bits and pieces you need. So I'm going to copy that in. I keep hitting Control C. I still haven't figured out the difference between Control C and Control V. Okay, Control V, and then play that. And then we should be ready to play anything we want to with respect to answering questions. So I can see here now the code for evaluating this line integral is right here. Let me just go ahead and copy and then paste it over. So Control V, paste. Right. So this part is the code I need. So in your Word document, all right, let's see what I need in my Word document. And the snipping tool, you should be able to find it in your search on your computer. Just type in snipping and you'll find it. And what that does is it allows you to take pictures of basically anything you're working with. So if you go over to WebAssign, okay, I want to do number 9 for Mr. Stroop, and I do my snipping tool. I need to get this out of the way, like this, and I just snip in number 9. You should already have it answered, and then you could go over to Web and just paste it in. Okay. You can make it smaller so you don't send me 20 pages of material. It probably is going to drive me crazy. So don't send me too much. So this is basically my first problem, right? So I'm going to hopefully be able to move that down a little bit, and then I'm going to just put like number 1. This is my first problem from WebAssign. You don't have to be too detailed, but as long as I can kind of see where you start and end the problems, I should be good, right? So the first problem from WebAssign is that thing. Then I need the code. So let's go over to where the code is. You don't have to put in all the packages and stuff, just the code that evaluates the particular problem you're working on. So I'll do another snip. Here's my code. Well, I need to edit the code, right? This is the code for some other question that they have running in the problem set. So what they're doing right here is basically figuring out the line integral of this part right here. This vector field is square root z negative 2x square root y, and then their curve is t squared t to the 4th, and they're going from t equals 0 to t equals 1. But in WebAssign, our problem is our vector field is 3x, 6y. There is no k position in this case, so it's 3x, 6y, 0, and then t for the vector value for the curve t, and then square root 4 minus t squared from negative 2 to the 2. Okay, so I kind of have to edit the code in order to evaluate that thingamajig. So there's some small details, like for square roots, you kind of have to call out to get to the library that you're using. So you'll see SMP, which is SentPy, and you literally just hover over it, and it should give you a definition. You can see symbolic mathematics. The actual computations behind all that is extremely interesting. I studied that for a semester or two, just looking at the beginnings of all that with the SAINT program over there at MIT. The SAINT program was written by a blind student. He was given an award by the president for putting all that together. It's considered one of the first AI programs ever written. And it did integration as well as the freshman students at MIT in the calculus classes. So anyways, symbolic integration, in my opinion, much more interesting than numerical integration, where you're just spitting out numbers. Like your TI-84 could probably do any sort of integral, definite integral. So anyways, I'm going to go through, and I'm going to, so you can see the bits and pieces I need to kind of edit if you toggle back and forth between this web page. So I need to replace, I want this vector field, right? So I need to replace this vector field, this f equals square root z minus 2x. I don't know if you can see my cursor, and I need to fix that so people can see my cursor in the future. But anyways, you're going to go here and replace this thing, right, with just 3x. So the first component is 3, and you can't just put 3x. You have to tell the computer it's multiplication. So you have to put a little star there. Okay. The next component is 6y. Again, you have to tell the computer it's multiplication. So you put a little star there. And then the third guy is just 0. But on the curve, I need a square root function. So I'm going to kind of keep that there so I can copy that code. That's in case I forget how to type in SMP dot square root. So the square root function, squirt is square root, and we want 4 minus. And then another thing that the code for exponents is double star. Okay. So you can kind of back engineer a lot of it because they're going to be giving you examples in the code where they've translated, or you could see the translation from the actual function into the code. So you can see the y component here for the curve is t dot dot 2. And if you look at the output above, r of t equals t comma t squared, so it must be that t dot dot t star star 2 is really just t squared, right? Okay, so I think we got that. I put too many p's in there. And the first component is t, so we're not going to change. Oh, we need to change this third component in the field to 0. And then I need to change the last component on the curve to 0. And then I need to change the t values. They're going from -2 to 2. So in this case, it's going from 0 to 1. So I think we could just go -2 to 2. Okay, and then you should push the play button. It should output 0, which it does. Okay, so I go over there and I snip that code. And that's basically what I need to see then on the second part of this. So I said there's 3 parts I want to see, but it's actually just these kind of 2 parts. So you got to copy in the question with the answer, and then the code with the answer. So let me edit my original. There's just 2 things. So it's the question with the answer, and secondly, the code with the answer. And you basically just need to go through 10 of them. I'm only allowing 10. Anything more than that wouldn't be fair. 2 points each, 20 points. Yeah, so good stuff. Hopefully you'll enjoy doing that. It'll be empowering for those of you who have never really done coding. I think you should be able to figure it out. If you don't want to do these harder ones like this one, just focus in on maybe doing like triple integrals. Those probably be a little easier to kind of figure out than maybe you're not on board yet with the vector type stuff. Okay, and then in the future, if you are having, for whatever reason, having to do tons of these, you can use this guy as a resource. He also does the first year calculus in Python. Really, really cool stuff. Okay, okie dokie. So I'll leave that as your extra credit project as usual. Thank you for watching. I'll see you next time.